Let's solve diameter of a binary tree. Now, even though this question says it's supposed to be an easy question, this is definitely way harder. It's probably more like a medium question. And when I first tried doing it, it actually took me a really long time to figure this out. But don't worry, I promise you by the end of this video, you're gonna understand how to do this. And if you don't, I'll PayPal you personally $1,000. So let's go. So what is the max diameter of a binary tree? Well, the diameter of any node can just be summed up as the number of edges in the right tree as well as the right tree. So if we look at root node 1, it'll be 1, 2, 3, 4, a length of 4 for the diameter. You might think that the root node is going to be the max diameter, but it's actually not, because look at this. What if we took the node 2? Well, its left subtree has 1, 2, and then the right 3, 4, 5 edges. So actually the max diameter of this binary tree would be 5. So now you may be asking, how can we find the max diameter of this binary tree? Well, any single question with the tree, we know we can solve it using DFS. So how can we find the diameter of a single node? Well, if you remember, the diameter of a single node is just the height of the left subtree plus the height of the right subtree. Now that we have the diameter formula, we can very easily finish the rest of the problem. So we start off with a DFS search. We start here, 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 and here. And technically DFS will go to here, but because this is null, we can start backtracking. So now that we're at 6, what do? During our DFS search, for each node, we want to find the diameter and the height of the node. So here in the steps, you can write that first in DFS, we want to find the diameter. And then we want to find the height of the current node. So how do we find the height of a node? Well, let me show you the height formula. The height formula is just the max of the left subtree height and the right subtree height plus 1. Now, why is that the case? Well, if you look at the height of any node, say we took 2, right? What is the height of 2? Well, obviously we can see that it's 1, 2, 3, 4 is going to be the height, right? It's not going to be 1, 2, 3 because this is the shortest path. We want the longest path for the height every single time, right? So that's where the max of the left subtree and the max of the right subtree comes from. Now, where does the plus 1 come from? Well, if you look again, remember, there's 1, 2, 3 height in the right subtree, right? But we also need to include the 2 as well. So it's really 3 height plus 1 is equal to 4 height for 2. So that's where the formula of height comes from. Now that we have the formula of height, we can start solving. Well, remember, we're back at 6, right? So we need to find the diameter and the height. Well, the diameter, remember, is the height of the left subtree and the height of the right subtree. Well, technically, the height of both of these is going to be 0. So 0 plus 0 is going to be 0. Now, what's the height? Well, again, the height is the max of the left and right, and technically that's both 0. So 0 plus 1 is going to mean a height of 1 for 6. Now we can go up to the 4. Well, 4 via depth first search, we have to go down to 7. And 7 is exactly like 6, right? It has a diameter of 0 and a height of 1. And now we get to the interesting part. Now that we have done 6 and 7, we pop back up to 4. Now for 4, what is the diameter? Well, remember, the diameter is the height of the left subtree and the height of the right subtree. So look at this, that's the height, that's the height. So we have a diameter of 2 now for 4. And that makes sense, right? Because 1, 2, that's the diameter, 2. Now we also have to calculate the height as well. We can't forget about the height. And the height, again, is the max of the left subtree and the right subtree height. We can see that it's 1 and 1. The max of 1, 1 is just 1. And then 1 plus 1 is equal to 1. Alright, I'm stupid. That's equal to 2. So we have a height and a diameter of 2. And let's see, does this check out? We need to make sure that it actually checks out. And yes, it does. Because remember, the 2 diameter is 1, 2. And what's the height? We have 1, 2. So everything checks out. And now that we have the formula for both the diameter and the height, we can see that the rest of this problem is really quite trivial because we can just run these formula on every single node in the entire subtree. Now, one thing we need to remember to do is as we're running the DFS on every single node and finding the diameter, each time we find a new diameter, we need to make sure that that diameter is actually the max. So how can we do that? Well, we can just write a max variable and initialize it as 0. And every single time we find a diameter bigger than max, we can just change the max. So for example, at the 4th node, we have a 2 for diameter, right? And 2 is definitely bigger than the 0. So that we can change that 0 into a 2. Now let's run it again. Let's run it on the 2nd node. Well, for the 2nd node, we gotta go through everything here, but I'll just do it real quick for us. So I just filled in the right subtree, and now we can try to find the diameter and height of 2. So let's look at our formula again. What's the diameter? The diameter is the height of the left subtree plus the height of the right subtree. So the height for the right is 3, and the height of the left is 2. So we have a diameter of 5. And then again, the height is, we take a max, so the max height is going to be 3 plus 1 equal to 4. And let's check it out if it matches up again. So again, diameter 5, 1, 2, 3, 4, 5, that checks out. And a height of 4, 1, 2, 3, 4, that checks out as well. So now that we finished processing the second node, we need to check if the 5 is bigger than the 2, and we know that it's going to be bigger than the 2. So we can change the max now to a 5. So now the max is going to be 5. And technically 5 is our answer, but remember, this is depth first search, so we still need to finish it for the rest of the tree. But just to save some time, I'm going to do it out for 1 already for you. So now we can see that for the first node, it has a diameter of 4 and a height of 5, right? And we already know that the formula, by using these formulas, it checks out. Now, do we check is 4 bigger than 5? No, of course not. It's not bigger than 5. So we don't have to do anything with the max. And now we can see that since the max didn't change, it's actually going to be the correct answer. If the max did change and we change the max every single time to just what the current node says, by the time we get to the first node, it's going to give us the wrong answer of 4. So make sure the max only gets the max diameter each time. And that's it. We found the answer. Let's code it up. Alright, let's write the code now. Remember, we first want to initialize the max variable. This is going to be the maximum diameter of our DFS search. Now we want to write the DFS function. So we can write the function like this, and it will take in a current node. And what does this function return? Well, this function is going to return the height of the node. And what's the base case going to be? Well, remember, the base case is going to be if the node is going to be null, right? So if the node is null, the height is going to be 0. So if not cur, then return not null, sorry, it returns 0. So now that we know we're in the actual node, we want to find out what the diameter of this node is, right? So we can do a let diameter equal to, remember what was the formula? The formula was the height of the left subtree and the right subtree. Well, we don't have that yet, so we can create a left is equal to DFS of current left, and let right equal DFS of current right. And remember that these two functions is going to return the height of the node, so return the height of the left and the right node. So we can just do left plus right. Okay, now that we have the diameter, we need to check if this diameter is bigger than the actual current max diameter. So we can just do it like this. And then remember, this DFS function returns the height of the current node, right? And what's the formula for the height? The formula of the height is the max of the left and right subtree plus 1. So we already have that. We have max of left and right plus 1. Then we make sure to call DFS on the root node, and then we return max. And yeah, it's done.